Hi guys, I'm going to go through the entire exam. So if you want to like skip through it, you can. It's optional even to watch this. So it's just easier for me to do the whole exam at once instead of making a bunch of separate videos. So the first one, use a limit definition of the derivative, none of the rules, to find the derivative of the function below. There are two limit definitions. You may use either one. So a lot of you got like just 1 point off on this, and it was just for notation. All right, so I'm going to do it. I put a line down the middle because I'm going to do it two ways. All right, this first one, I'm going to use the fact that, okay, so I'll do the f prime of c definition. So f prime of c equals the limit as x approaches c of f of x minus f of c all over x minus c. That's one of the limit definitions of the derivative. And the other one over here, I'll do f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so if you want to see the first one, just stick around for this. If you want to see the second one, fast forward till I get there. Okay, so I'm going to go f prime of c equals the limit as x approaches c, and then f of x is just 2x squared plus 4 minus f of c is 2c squared plus 4 all over x minus c. And you cannot direct substitute. You can't just plug c in for x because then you'd get 0 in the denominator. So at this point, and those of you who got points off because of notation, you should really just stop and leave a blank, and then down here go like aside or something. Take the input and simplify it until you can get the factor of the denominator that is not allowing you to direct substitute. So this x minus c is not allowing us to direct substitute because it gives us 0 in the denominator. So you've got to like simplify till it cancels. So you get 2x squared plus 4 minus 2c squared minus 4 over x minus c. Those 4's cancel. And this is equal to 2x squared minus 2c squared over x minus c. And then from here you could factor out a 2, and you get x squared minus c squared over x minus c. And then that's a difference of 2 squares, so you can factor further, and there it goes. That factor cancels. So now I take my simplified version and I plug it back in up here to x plus c. Now I can direct substitute. And when you direct substitute, you drop the limit. So this is 2c plus c equals 2 times 2c equals 4c. And then maybe I'll just go like this. Therefore, f prime of c equals 4c. And at the end, when you do the therefore, you could switch to x's. All right, now I'll do this one. So this is going to be, so I've got f prime of x equals the limit as h approaches 0, and f of x plus h, this is 2 times x plus h squared plus 4 minus 2x squared plus 4 all over h. You cannot direct substitute because that would give you 0 in the denominator. So you leave a blank like that, and then down here you go aside. And then I'm going to have 2. When I multiply x plus h times x plus h, do it slowly if you want, but you'll end up with that plus 4 minus 2x squared minus 4 all over h. Okay, so these are canceling right away, so that's good. And then you end up with 2x squared plus 4xh plus 2h squared minus 2x squared all over h. The 2x squareds cancel. So this is 4xh plus 2h squared over h. And you can factor out an h, and you get 4x plus 2h all over h. Those h's cancel, and now I take this and I plug it back in up here. 4x plus 2h. And now I can direct substitute. So this is equal to 4x plus 2 times 0 equals 4x. Therefore, f prime of x equals 4x. Okay, number 2, given this function, at what point or points is the slope of the graph 10? This is the derivative. Okay, derivative. All right, so I've got to take the derivative and set it equal to 10. So I've got f prime of x is equal to 3x squared. And then I take the derivative, I set it equal to 10. So this is the derivative, that's the slope. I want to know at what x values it's equal to 10. So I divide both sides by 3. X equals plus or minus radical 10/3. Some of you forgot the plus or minus. And then you can use your calculator from here, or you could just go like this. So radical 10 over 3, comma, I need the y coordinate. And actually, I saw only one of you did this. I didn't even think to do it like this. I was like plugging in and getting a number, like a decimal, I mean. But just take this, so you've got to take these x coordinates, plug it back into the original function to get the y coordinates. And I saw one of you go like this. It was awesome. You just went radical 10/3 cubed plus 2. And that's negative radical 10/3 cubed plus 2. And I loved it because in AP Calc you don't have to simplify. So there's that. Now, this one here, this function is graphed at the right. The graph is just a sketch, it's not drawn on a scale. Find the slope of the line that is tangent to the graph at x equals 1. All right, so it doesn't hurt, guys, if you were to draw yourself like a tangent line. You don't have to, but it doesn't. It also might help you visualize what's going on. Okay, so this is the tangent line. I want the slope of the line that is tangent to the graph. So they're asking for the slope of this tangent line. And the slope of the tangent line is the derivative. Okay, so m tan, the slope of the tangent line, is equal to f prime of like whatever x value you want. And here we want that. So I'm going to find f prime of x. This is 3x squared minus 5. So f prime of 1 is equal to negative 2, 3 minus 5. Then down here, find an equation of the line that is tangent to the graph at x equals 1. So I need to know the point of tangency, and I need to know the slope of the tangent line, which I know is f prime. So the point of tangency, what I do know is that its x coordinate is 1. It's this point that I'm looking for, the x and y coordinate. I know that the x coordinate's 1, so the y coordinate I'm just going to get by plugging 1 into the original function. So f of 1 is 1 minus 5 plus 18. So that is 18 minus 4, right? So 14. So there's the point of tangency. Now the slope of the tangent line, we've already got that. It's negative 2. And then you just go y minus blank equals x minus blank. So y minus 14 equals negative 2, x minus 1, and you are done. You don't have to solve for y. Okay, now on to our derivatives. So for 4 through 7, use the differentiation rules that we have learned to differentiate, which means take the derivative of the functions below. You do not need to simplify your answers. Okay, so I'm going to go super slow. So I'm going to start off by going f prime of x equals, so I'm going to have to take the derivative of each term, okay? Now, the derivative of this is going to be pretty simple. All right, it's just going to be 3. Plus, for the derivative of this, I need product rule. So I'm going to set up product rule, and you do not have to go as slow as me. But if you're watching this, I'm assuming it gave you some trouble, so that's why I'm going to go super slow. So this is 4x sine of x, 4x sine of x. This just keeps coming down. We already took the derivative of this, so that's just 3. Plus, derivative of 4x is 4. Bring down the sine of x. I know I didn't have parentheses before, but I like to put parentheses around the input of a trig function, just out of habit, so I'm going to start doing that, even though they didn't even have it at the beginning. Plus, bring down the 4x. The derivative of sine is cosine. So that is that one. Okay, now this one. So I'm going to take the derivative of each term. So I've got this first term plus I've got this term that I've got to take the derivative of. Now in this first problem, we just did regular power rule and then we had to do product rule. This time, similarly, we're going to do regular power rule. So the derivative of that is just 2. Plus, for this one, I'll do it off to the side. For this one, you need chain rule. So off to the side, I'll go inside, outside. Inside is 6x squared plus 10x plus 1, cosine of blank. The derivative of the inside function is 12x plus 10. And the derivative of cosine is negative sine. And then you just have to take what used to be inside and plug it back in. So this is going to be 12x plus 10 times negative sine of 6x squared plus 10x plus 1. You could leave it like that, but I'm just tempted to take this negative and, change that plus to a minus. Because if you're adding a negative, you're subtracting. So, and you know that. It just looks a little more professional. But you don't have to do that. Okay, 2 more. All right, so this first one, we had to use power rule and then product rule. The second one, we had to use power rule and then chain rule. This one, we're going to have to use quotient rule inside of chain rule. All right, so you've got to go, so right off the bat, this is just a single term thing. I have to take the derivative of the inside and then multiply it by the derivative of the outside. The derivative of the inside is that. No, that's just the inside. And then the outside is blank to the 6th. Now for the derivative of this inside one, I need quotient rule. So I'm going to set it up. Minus. Okay, that's off to the side. And then all over this. Okay, so 9 minus x to the third, 3x plus 5. 9 minus x to the third, 3x plus 5, 3x plus 5. Okay, so the derivative, so I'm going to get y prime equals, and I'm not really going to be super fancy. I'm not really going to simplify much at all because it's going to be messy. So the derivative of this is negative 3x squared. Bring down the 3x plus 5. So I'm just bringing that one down there. Minus, the derivative of this one is just 3. So I'm going to bring that there, and then I'll take 9 minus x to the third and bring it down. You could have the 3 at the end, but usually coefficients go in front. 3x plus 5 to the second. Okay, that's the derivative of the inside times the derivative of the outside function is 6 blank to the 5th. But what goes back in the blank, what used to be there before. So this is going to go back in the blank, what was originally the inside function. So there is that. And one more. So this time, this is a double chain rule one, because you ask yourself, where does the input go? So the input is x. Is it just an x that is inside of the tangent function? No, it's 2x. So if it's not just x that's the inside function, you know you've got to use chain rule. So it's 2x that's inside of tangent, but then tangent is inside of natural log. So you've really got two things that are inside of other things. So I'm going to go in, out. So the innermost function is 2x. You could always say that the innermost function is x, but that derivative is just 1. That's why we don't usually say it. And then we've got tangent of blank and the natural log of blank. The derivative of 2x is just 2. The derivative of tangent is secant squared of blank, but what goes back in that blank is what used to be there to begin with. So that's a 2x that goes back in, times the derivative of natural log is 1 over blank. Most of you said the derivative of natural log was still natural log. Not most of you, but most of you who didn't get it. But the derivative of natural log is 1 over blank. And what goes back in this blank? Well, tangent used to be inside there, so tangent's got to go back in. But what used to be back inside tangent? 2x. So, in the end, you get that f prime of x is 2 secant squared 2x tangent 2x. All right, guys, that was crazy. It only took me like 16 minutes to do that. But the reason is I'm not patting myself on the back. I do this a lot. And that's how you get faster and more efficient at doing anything, really, is just by doing it a lot. All right, I'll talk to you soon. Bye-bye.